Hi, we are from group 14 and we are going to talk about point load test. For the introduction, the point load strength index and unconfined compressive strength are determined by performing a point load test on core rock specimens or irregular rock fragments. This test does not necessitate the preparation of a pricey specimen and is rapid and straightforward test. The uncorrected point load strength P over D square is calculated by measuring the failure load P and the distance between platens D. The unconfined compressive strength is calculated using a correlation equation after a correction for specimen size and shape is performed. Three types of tests can be done depending on the specimen geometry, which are diametral, axial, and irregular lump. ISRM 2007 recommends the testing methodologies. The purpose of the irregular lump test is to assess the compressive strength of rock specimens. For the theory, the point load strength test, which was first presented to predict uniaxial compressive strength and eventually become the standard test for general purpose rock strength classification, and was primarily used to predict uniaxial compressive strength when it was first introduced. Point load strength has largely replaced uniaxial compressive strength in this position, as it is both more reliable and faster to measure when done correctly. Because correlations with uniaxial compressive strength are simply approximation, the point load index should be employed directly for rock categorization. Uniaxial compressive strength is 20 to 25 times point load test on average. However, in tests on a variety of rock types, the ratio can range from 15 to 50, especially for anisotropic rocks, implying that using an arbitrary ratio number to forecast compressive strength from point load strength can result in inaccuracies of up to 100%. The point load strength test is a type of indirect tensile test, but its major significance in rock classification and strength characterization is mostly unimportant. The uniaxial tensile or Brazilian tensile strength is roughly 0.80 times the point load strength index.
The procedure for the point load test is, first, we need to take the irregular rock sample and then we measure the dimension of the rock sample. And then we place the sample between the pointed loading platens. And then we set the hydraulic reading, and after that we compress the rock sample until it breaks. Then we record the maximum pressure of the rock that it can withstand. Thank you.
For the data analysis, we will use the following data to calculate the point load strength. We first calculate the width, followed by the cross-sectional area, equivalent core diameter, and the size correction factor. With the area and core diameter, we can find the uncorrected point load, and lastly, we will calculate the point load strength. Here is the end results for all three tests.
My name is Atira. So we will be moving on to discussion for G4-3 point load test. So from the calculation and the data that we have obtained, sample 1 has the greatest value of point load strength, which is 6.4955 Newton per millimeter square, followed by sample 2, 4.1623 Newton per millimeter square, and sample 3, for 3.9340 Newton millimeter square. And as you can see, 6.4955 have the highest value. And then after that, we will calculate the correction factor. And then from the experiment, there is error occur during the experiment from the percentage difference. So some precaution we can consider, which is the ice must be perpendicular to the scale measurement during observe, and multiple readings also can be taken to get an average for us to obtain more accurate result by getting the average. Next is conclusion. It can be concluded that the objective of the experiment has been achieved, which is to determine or to assess the compressive strength of rock specimen. And from that, we obtain the value of point load strength. Thank you, and that's all from group 14 G4-3 point load test. Thank you.